Okay, good morning everybody. So far in this class we have done 3 modules as you might have seen in Canvas. One is on the cyber kill chain from Lockheed Martin, and then we talked about unified kill chain, and then we talked about MITRE attack framework, right? So these are all from the perspective of the attacker. Right, so the attacker's perspective is understood hopefully from these 3 modules. So today we are going to start a new module which is about defensive side. So we are going to look at the MITRE DEF3ND framework, and MITRE DEF3ND framework basically connects digital artifacts or the entities, digital objects like an URL, like a binary file, like an IP address, various types of digital objects or artifacts that are found when an attack happens or when the attack is ongoing. And based on those digital artifacts, you do detection, you do forensics afterwards. So this is DEF3ND is another knowledge base from MITRE that catalogs the various tactics the defenders can use to defend the infrastructure that they are supposed to defend against the attacks. So once we have understood the attacker's side, we are actually going to the defender's side. In that context, few things I want to say here. One is that the CTO of MITRE and the Senior Vice President of MITRE Labs, Charles Clancy, is going to be here tomorrow and day after, and he is giving a talk at 4 p.m. tomorrow at RM 101. So if you want, you can join at RM 101 and hear directly from the MITRE CTO. Although he is going to talk about post-quantum cryptographic, post-quantum preparation for internet in general. But this is something you might actually want to attend. Second thing is that tomorrow's class I will record and I will provide the recording because tomorrow I'll be in another meeting. So those are the 2 things that you have to think about. Now, before we go into MITRE DEF3ND framework, let me, as usual, go into finding out where you are. By the way, so you can use menti.com and use that code. The midterm exam was quite disappointing. People have not done very well so far. Majority of the reason is that people are not coming to class, so they are not listening and they are not necessarily also studying the material. So it was quite something. So I want to see where we are. So here I have a sentence from a threat report, and I am asking which tactic is here. So everybody thinks this is defense evasion. That is right. It's very clear from this sentence that this is about defense evasion, and certainly this is not reconnaissance or impact. Right? This one simple. So what defense you would use? What would be your defense recommendation for this? That the attacker is bypassing security tools, so antivirus is what the attacker first switches off, right. So this is antivirus usually runs, and you can actually configure it to be switched off, right. So antivirus is probably not the right solution. Network intrusion detection will not tell you what is happening inside the devices, right. So the defense tactics are being evaded at the endpoints, right. So endpoint detection is probably what you need, right. Okay. So let's see another tactic question. Before executing these attacks, it registers domains to free DNS services. Okay, so this is certainly not persistence or defense evasion, right. You are basically trying to create this command and control. If resource development was given as one of your choices, then it would have been resource development, right. But I intentionally did not give that choice, so that you can say command and control. So so now another one, the downloaded executable performs known UAC. UAC is what is UAC? User access control, right. So UAC bypass through event viewer registry hijacking to get the highest privilege, right. So now you are getting highest privilege, so there is no question that this is about privilege escalation, right. But after having seen the results of the midterm first question, I wasn't sure that even this will be 100% here, but I am pleasantly surprised. So here is the downloaded executable performs UAC. What will be your defensive recommendation? See, the sentence is saying that there was an UAC bypass which is already a known UAC bypass. What does that mean? That means there is a known vulnerability in this event viewer registry, whatever the component is. So the reason why it happened, the threat actor could exploit it, is because you did not patch it in time, right. So patching is the solution defense recommendation. Firewall and anti-malware will not help you here, right, because you have left unpatched components, right. Okay, so and then about this domain thing, what would be your defense recommendation? So how will the hardening of the OS help here, right? It won't help, right? You have to check whether some unknown domains are being contacted by your machines, so that you know that there is a command and control activity going on. So the situation is pretty scary. Now what can we do, right? So we cannot really now this is actually the sliver of students. So I have 83 students, 84 actually. One person I am going to deregister. 83 students, and in this class right now there are about 25 students, right, and that's the normal attendance in this class. Now what that means is that even those who are coming to the class, there are a few who are actually getting this wrong, but think about the guys who are not even here, right. So that's the majority of the class, and the majority of the class doesn't have any idea what's going on. So I do not know what will happen at the end. Now remember you have a project also, right, class project, and the midsem is over. So it's time to think about the project, right? And I think I have already declared, if I haven't, that I have 31 teams right now, right? 31 teams? How many teams I have? 31 teams. Now I have actually 83 students, which means that I have, if I create students teams of 5, then I will have a 16 teams. I will put 3 more in different teams, right? So I'll create 16 teams, right, for the semester project, each having 5 students. Now the question is that what project do you want to do, right? So last year, for example, people had done tools for risk assessment. We will talk about risk assessment after this topic, right? So how to do some risk assessment. People did some tools for interaction. We also have resilience measurement. So I think there was some tool for resilience measurement. What were the other projects last year? Anybody remembers? So you can do malware analysis tool, or you can do let me see. So everybody submitted GitHub link. Okay, so I will post some possible projects. I think I cannot. I have to find out how it was submitted, but I will check that. But you have to start thinking about what project you want to do, right? Okay, so let's come back to the next module, that is MITRE DEF3ND framework. So MITRE felt that their attack framework was very successful. Everybody was referring to it for describing how the threat actors behave in their system. They were being used to describe the modeling the behavior of the malware. They were being used to exchange threat information between various organizations and CISOs. So they felt that they have done quite well with respect to cataloging the various tactics and techniques, and they treat this as more like a knowledge base, but then they also have other resources that they developed over time that they could relate to the MITRE attack framework. So one of the good resource that you might have not seen is MITRE Cyber Analytics Repository, or CAR. So this is a very useful site for a knowledge base for those who are working on cyber security, especially those who are working for operational cyber security. So if you go and look at their full analytic list. So now what is analytics? This analytics is basically for detection. So you actually want to detect certain things. For example, here is, and they named these analytics methods, and this is a living document, which means that you can add more analytics here in the future. So here, for example, I'll show you one of them. This is the what they call auto run, right? So auto run is basically detects whether somebody has created or modified a system process or scheduled a task or a job, or login auto start execution, execution flow hijacking and all that stuff, right? So auto run is actually a software that you can get from, so you can download auto run from sysinternals. So Microsoft sysinternals gives you a lot of tools. So auto run is one of those tools. So if you actually look at auto runs, so here for example, so it will tell you what are the different tasks and processes that are running, right? And from that you can check whether their signature has been the binary from which this process has been created, whether their signature is matching with their original creator's signature and so on. Then you can actually check whether your system has something suspicious. That doesn't mean that you will always be able to detect it, because many times signatures are digital signature. It has been the case that many attacks, the digital signature of legitimate actors have been stolen and used, like in case of Stuxnet, but at least it gives you visibility, right? So for example, I have one process running here whose signature is not verified, right? So I should be suspicious, although I know what it is. This is for similarly, here I have was a service for which the file is not found. The agent file has not been found. So there is some problem here. This has been part of my startup folder or auto run, but it is not there. Here is a Microsoft driver which seems to be not verified. That is highly suspicious. Here is another one for which file has not been found. So auto run basically is a tool that gives you some idea about what tasks are running automatically in your system, and what binaries they are running from, and whether the binary has been digitally signed, and whether the signature has matched. And then you can, from that you can make certain inferences. It doesn't mean that you will stop all possible persistence type of tactics, but it gives you some idea. So, but the point here is that, for example, if you want to know whether there are SMB events. SMB is the SMB protocol that is for communication. So I want to know whether there are some SMB events. So here, what they are giving here is a Zeek script for detecting whether at port 445, where SMB protocol runs, something is happening, right? So this tells you, so you can use it in your system. So in your detection system, so in your network intrusion detection system. So what I'm trying to show you is that this is an excellent resource already for getting various scripts and tools that exist right now for detection of various things, various tactics that MITRE attack framework already given. There is also another resource called CAPEC. So sorry. So this is the common attack pattern enumeration and classification, right? So this is also dependent on CAPEC, dependent on MITRE framework. and the common weakness enumeration, right. So, common weakness enumeration is the common weaknesses in softwares and systems and hardware also. So, what MITRE felt is that since 2008-9 when they came up with the attack framework till 2018 when they came up with the framework of DEF3ND, between that time they realized that their frameworks and the resources that they are creating associated with the framework together is creating a lot of impact, and they realized that we could actually do more impact if we actually catalog the various defense tactics and then connect this defense tactics with what we call digital objects or digital artifacts, which we actually capture to detect or do post-mortem, like do the forensic analysis, right. Because attacks usually leave behind certain footprints or certain signatures or certain digital objects like a malware or an URL that has been accessed or an IP address that has been accessed or some messages that came for phishing. These are all digital, what we call digital artifacts. These digital artifacts are very useful for forensic analysis, and therefore they are really connected to they connect the attack and defend framework, right. Because attack is basically various tactics and techniques that generates those artifacts, and defend often uses these artifacts to create the defense mechanism such as detection, right. So that's what the history of the DEF3ND framework. So that was the need for a model that can identify and precisely specify the countermeasures that you have to take against the various attack techniques and tactics. So they actually went through various patents, research papers, websites and so on to figure out what are the different countermeasures that people are using, what tools they are using as for countermeasure and so on between 2001 and 18. And then they decided that okay, so any kind of technology or process that somebody uses, I should catalog them. And the reason why this is important is because, like we understand now the threat actors' activities in terms of 14 tactics, it is important as a CISO or as a cybersecurity architect of my organization to understand what are the different countermeasures and how to classify them as something is for system hardening, something is for detection, something is for eviction, something is for deception. So all these different tactics. And also a red team that is conducting a red team exercise should also understand the countermeasures so that they can try to evade them, right. So that's the test of the security, or that is what the blue team is supposed to do the security, and red team is supposed to break the security. So the red team has to understand what the blue team has done with a standardized vocabulary, right. So that there is no misunderstanding of what they are doing. So this is what the DEF3ND metrics looks like. So we have all seen attack metrics. So this is the DEF3ND metrics. So in DEF3ND metrics, we see on the top there are 5 tactics. So this is much more manageable because there are only 5 instead of 14. So first is harden, second is detect, isolate, deceive and evict. So these are 5 different tactics. And there is even though this is supposed to be like attack, this is a knowledge base. Like in attack, we don't say that these are sequential, right. So we say that, okay, one can actually do reconnaissance once it is inside your system. It has done execution, persistence, maybe privilege escalation. At that point, it can again do reconnaissance. And that was the basic idea of unified kill chain, right, that you can have this thing round and round again and again, right. So there is no really implied sequence in the attack framework, but implicitly there is a temporal relation, right? So without a execution, you cannot think about persistence, or without persistence, without persistence you can do a lot of things, but lateral movement requires for execution first, right, and things like that. So here also, like unless you detect, you cannot isolate, right? So you have to isolate a system only after you detect that there has been an attack. Similarly, if you cannot evict unless you detect, right? So there is some temporal relation between these tactics, but normally we treat this as knowledge base, and from a knowledge base point of view, we say that okay, so these are 5 tactics, and then there are sub tactics, right? So sub tactics in the sense that hardening is the process of creating better configuration, better ability to tune the system, so that tune the protective measures, or tune your software so that it does not fall victim to an exploitation. So that's a hardening process, right? So in here you see that there are application hardening, credential hardening, message hardening, platform hardening, right? So we'll go through this in detail later, but just to give you an example, application hardening, right? So what is an application hardening? So you write an application, you compile it, you run it, and then there is a buffer overflow vulnerability in it, right? Or it has a privilege escalation vulnerability, or it has a null pointer access vulnerability, right? So you have to actually test for those, or you have to run what we call SAST tool, or static analysis tools, or dynamic analysis tools, or DAS tools, to find out those problems, right? And then we have to fix them, right? So fixing them will harden the program, right? But you can also harden it by doing other things. So those of you who have taken a class on application security, you have seen that we do various things to stop the application from falling victim to buffer overflow vulnerability exploitation, like we do, for example, address space layout randomization, right? We actually do use canaries, right? We actually do what is called DEP, or the data segment execution prevention, right? So there are various techniques we use to stop a program from executing a buffer overflow, right? So similarly, you can do various things to ensure that your code does not have exploitable segments, right? So there is something called return oriented programming that is used to avoid these protections against buffer overflow. So we actually do date code elimination to actually make sure that there is no part of the code that is not used by the program, but it is unnecessarily there, because somebody can then use it for return oriented programming type of attacks, right? So application hardening has many different techniques. Now this is not an exhaustive list of techniques, it can increase tomorrow. Like if you go to Defend website, like 6 months later, you might find few more in the application hardening, right? So document. Similarly, credential hardening, right? So multi-factor authentication is a credential hardening, like hardening technique, right? So message hardening, message authentication, message encryption, and the API security would fall under message hardening here. Platform hardening, you do disk encryption, you do integrity checking, like we were seeing, that verification of the binaries and their signatures and so on. So similarly, detect has multiple different sub tactics, like file analysis, which basically is malware analysis and other types of binary analysis, identifier analysis, message analysis, and so on. So then you have network monitoring, platform monitoring. So these are intrusion detection, network intrusion detection, platform endpoint intrusion detection, and so on. Then there are isolation techniques. So network isolation, like network segmentations, and then you have this execution isolation, like putting things in separate virtual machines, or putting them in the different containers, or putting executions inside enclave. So these are techniques that are related to isolation. Deceive is when you create decoys like honeypots, right? So, or honey credentials and so on. And evict is once you have detected that somebody is inside your system, some malware is running in your system, or somebody has access to your system through a compromised login or through user authentication bypass, you have to evict them, right? So you have to, stop them from being able to execute inside your system. So this is the overall first look at the defend matrix, right? So you can recognize all of these if you have done anything related to cyber protection of your own system, or on somebody else's, in some organizational system. You recognize all of these. You try to do many of these things, but this is a way to give them some kind of a framework in which they all are positioned. So now defend is considered a, yes? I cannot hear you. Can you tell? Right. So this is possible because this will be this is a living document, right? So now you have this diagram. Now this is something that is little problematic for you because you are not really familiar with semantic web and this entire knowledge graph. It's a whole community that is a knowledge graph community. And in this community, everything is, every kind of concept is put in an ontological context, right? And there is a connection established between different concepts, and there is a knowledge graph created. And there are knowledge graphs in various domains, right? So there is a entire open communities who are involved in creating knowledge graph. And if you look at the defend documentation, you will see that they see this in a much grander vision, right? That this entire defend and attack and artifact, this knowledge graph, will eventually be part of a much larger knowledge graph, which eventually will be used by AI, generative AI agents and so on to actually answer questions and so on and so forth. But just to give you an idea about what they are saying is, see, these yellow arrows are basically kind of like class derivation or hierarchy, class hierarchy, and the blue arrows are basically the what we call attribute relations, right? So defensive techniques, right? So if you think about defensive technique, obviously a more generalized concept is technique, right? Defensive technique is a special case of technique. Now technique is a special case of defend thing. Now what is defend thing is a concept like related to the defend knowledge base or defend framework. Anything in the defend knowledge base or defend framework is a defend thing. Now if you see, the technique is associated with a digital artifact, right? Because any technique will either create a digital artifact or consume a digital artifact. For example, if I want to detect whether there is a network, there is a command and control activity, I will look for URLs and IP addresses, right? So URLs and IP addresses are digital artifacts. If I want to know if there is a phishing, then I would look for some kind of a phishing message or email and things like that, right? If I look for malware, if there has been an attack on malware, then I will look for a malware artifact, right? So every technique is associated with a digital artifact. Artifact is a special case, is a generalization of digital artifacts. Artifact doesn't have to be digital, it can be physical artifact as well. An artifact is also a digital object, right? And a digital object or artifact, both are concepts within the different frameworks, so they are also different things, right? Now you see that digital artifact, okay, so digital object is any object, any file is a digital object, any URL is a digital object, any email address is a digital object, any kind of binary is a digital object. So you can think of any kind of digital objects, any kind of memory segment is a digital object. So you can have various kinds of digital objects. Digital object becomes a digital artifact when either an attacker creates that digital object or touches that digital object, or a defender consumes that digital object or touches that digital object or reads that digital object, right. So this is what the defend framework is saying, that any digital object may not be of interest. Only those digital objects are interest to me if they are being created or touched by an attacker, or if they are being used or read by a defender, right. So that becomes a digital object, digital artifact. Now you see that defensive technique has enables, like we know that techniques enable tactics, right. So that's why you have techniques under tactics. So defensive technique will enable a defensive tactic, and defensive technique usually has a reference. This is the documentation of the defensive technique, that is the technique reference, right. So, and they are also different thing, they are part of the defend knowledge base. So this is what what they call core knowledge model. So the concepts here are very simple as far as you are concerned. You are not going to create knowledge base or knowledge graphs and put that inside a semantic web database and all that stuff. But for you, important thing is to know what is digital artifact is, and what are the defensive techniques are, and what are the defensive tactics, and the fact that all these things are part of the defend knowledge base idea. Now, how do we defend normally, right? So we understand the threats by threat modeling, right? And then we find vulnerabilities. Then we consider the likelihood of a particular threat by exploiting vulnerabilities. So if you do not have vulnerabilities, then even if you say what is a threat, right? So you can think of, oh, somebody will steal my data, right? That's a threat, that you are thinking of threat. But if you do not have any vulnerability, which usually is not the case, you usually have some vulnerability somewhere, but if you do not have vulnerability, then your probability of that threat being realized is 0, right? But usually we will have some vulnerability, and if you will have multiple vulnerabilities, and that threat can be realized through any of these vulnerabilities. So the probabilities will add up, right? So probability of exploiting that threat through this vulnerability versus that vulnerability, all that stuff will add up, right? So you consider the probability or likelihood of a threat being realized, and then you also consider the impact of that threat on the asset, right, on a particular asset, right. So in this case, let's say your data, your research data, you are worried, you are doing PhD or masters and you are writing your thesis and somebody steals your data. Yes. Yeah, so threat modeling is the process of imagining what can happen. For example, let's say I have video cameras around the campus. Now I will not look for whether my cameras are accessible by outsiders, right, unless I have a threat in mind, right. So, I will model the threat that some external person may want to track a particular student, right, for stalking purposes. So, that is a threat model, right. Now, or you may want to say that some threat actor will turn off the video at a busy intersection on campus to create some physical attack, right. So, that is a threat model. Once I have the threat model, then I will start thinking, is this threat model actionable? Can somebody actually do it? Then I have to look for vulnerabilities, right. So, then I will have to figure out whether the cameras or the network has vulnerability which can be exploited from outside, and if it can be, then what is the likelihood, that is, what is the likelihood that somebody will be able to VPN into the network, our network, and do this. So, all these calculations will tell me the likelihood of that happening. Then I would have to consider what is the risk associated with that happening. Now, the risk associated with that happening could be considered high or low or medium depending on the other external exogenous information. Like, for example, suppose there is a terrorist attack going on around the country. At that time, the impact will be much higher than impact assessment will be much higher. So or it is on a particular busy day, like during the Tikriti, right? Then we will say the impact will be much higher. So in that way, I will consider the risk. So risk is basically threat times vulnerability times likelihood. So based on the risk, I will say, okay, these high risk things have to be defended first. If I have a budget for cybersecurity, then I will have to first do a risk assessment and then find out what is the highest risk asset, and then I have to put my resources first there. So that's the idea. So tactics are basically maneuvers defenders take against the adversary. The what of the action, what are they supposed to do? Are they going to detect? Are they going to evict? Are they going to deceive? These are the whats. And the techniques are the methods employed to achieve that what, right? So that techniques are basically what makes tactics actually work. So tactics are enabled by techniques. So this is a standard idea. And as I said, that there is an implicit notion of temporal state, that, for example, you cannot evict unless you detect, right? So even though we say that these are independent tactics, but usually some tactics cannot be done without a previous tactic being applied, right? So you cannot evict without detecting, for example. Or a defender has to harden first before the adversary penetrates it, right? So hardening is done as a part of the design of the system, right? So there is a implicit temporal relationship. Okay, so now as I said that the ATT-CK and defend are connected through the digital artifacts, right? So digital artifacts are important, and digital artifact ontology is a knowledge base that was created by MITRE, and it is still being developed, right? So it's again another living knowledge base. So as I look at the third one that I said, that a digital object becomes a digital artifact when a cyber actor, either defensive or offensive, interacts with the object in any way, right? So a digital object becomes a digital artifact when it is being touched or used or created by an actor, either a threat actor or the defensive actor. So the knowledge model here is concerned with capturing knowledge about digital artifacts relevant to known cyber actors and known technologies, not all possible digital actors. So you have to catalog all the possible digital artifacts and then you have to consider them, you know. For example, if you think about process injection, right? So you inject code inside a running process, right? So what would be the digital artifact? The digital artifact would be the content of the memory allocated to that process, right? So unless you actually have this concept that such a thing can happen, you will not think of that digital artifact at all. So that's the reason why this cataloging and knowledge base creation is that we can, things that I cannot imagine, somebody else has imagined, may be actually relevant to my organization. And then I have to refer back to this knowledge base. Okay, so I'll do this from here in the next class. Tomorrow's class I will record and upload. I am not, I have a meeting, and then day after tomorrow will then come from there. So I'm hoping to finish the DEF3ND framework this week, and then we'll start with the risk assessment in the next week.